Okay, I want to show you another approach to doing this type of problem, this linear speed and angular speed, because honestly, I always forget the formulas and I find it kind of hard to figure out what's my angle traveled, what's my different things I'm looking for. So I do a kind of scientific approach where if you find the units and you take care of the units will take care of you. So I start by asking myself, okay, I'm looking for linear speed. So what is the units of measurement for linear speed? And so linear speed is some sort of measurement in distance. So in this case, we have centimeters and time over time, which is seconds. So I need something centimeters over seconds. So I first ask myself, okay, so let's talk about seconds. How do I get seconds in the denominator? So what relationship do I know with seconds? Well, I know that one revolution around the clock takes 60 seconds. And so now I have one revolution over 60 seconds, but I also know that one revolution around the clock, so if I go around the circumference of this clock, I would, the circumference is the distance traveled by the tip of that hand. So that would be 2 pi r. So that's 2 pi times 10.2 centimeters. And so now my units have taken care of themselves because my revolutions cancel out and I have centimeters in my numerator and seconds in my denominator, which is my units of measurement for linear speed. So I just multiply that and divide and I get 1.7 centimeters per second. So I usually approach these problems using this kind of scientific approach. All right, now that we know about linear speed, we're going to learn about another type of measurement called angular speed. Angular speed can be determined by the angle through which a point rotates in a given time interval. Angular speed is angular rotation per unit time. So for the formula method for this is that angular speed equals angle traveled divided by time. And the symbols that's used for angular speed is an omega. Omega is equal to theta over t, where theta is in radians. So the formula approach, so I'm going to work this number 12 in the two different techniques. So here we're going to do the formula approach. So a blade of wind turbines are 116 feet long. The propeller rotates at 15 revolutions per minute. Find the angular speed of the propeller in radians per minute. So each revolution gives the angle. Each revolution gives an angle of theta is equal to 2 pi because 360 degrees around a circle, and in radians, that's 2 pi. And so, but we didn't go one revolution, we went 15 times around. So the angular distance traveled would be 30 pi. And so therefore our angular speed is equal to our 30 pi, which is our angle traveled, divided by time. Well, how long did that take? It took 1 minute. And so our angular speed here would be 30 pi radians per minute. All right, now let's try it the other technique. So let's look at the units method. So again, I look at what I'm trying to figure out. I'm trying to find angular speed in radians per minute because that was given to us, radians per minute. And so that means I need to deal with something relationship to radians and something relationship to minutes. Well, the first thing I know is I know 15 revolutions around the circle is equal to 1 minute. So I can do 15 revolutions is to 1 minute. And then I can multiply that by, now I need to get rid of that revolution. So I need one revolution is equal to some unit in radians. Well, one time around the circle is 2 pi radians. After canceling out our revolutions, that gives us 30 pi radians per minute. So I get the same answer. Whichever method makes most sense to you, you feel free to use the formula or the units method.